What do you do, Ben?
I write Ruby for my work. I work at a company called Wonder Capital. We do financing for commercial solar projects. And in my free time, I write Clojure.
Have you ever written any open source Clojure?
I have. I maintain a library called Expound, which will help if you use Clojure spec. It will rewrite spec errors to make them more human readable. So check it out if you use spec.
Thank you for helping the humans.
Does Cognitect like Expound?
I think Cognitect has a complicated relationship with Expound, I would say. No, they do. I've gotten some really great feedback from people at Cognitect. They've been really nice about it. I think they have sometimes gotten pushback about, sometimes it is overlapped into people saying, you know, why do the error messages in spec look like this? And they feel that they've worked hard to design them with a specific set of trade-offs. So I think they're happy with what they've designed, but they're happy to see other stuff, you know, in the ecosystem. So I've heard someone at Cognitect say there should be more, there should not just be one Expound, there should be many versions of Expound that other people make to sort of change that part of the library. They want people to experiment in that space. So have at it.
I've seen members of Cognitect do positive, say positive things about Expound on Twitter, so it must be true.
Cool, you ready? Well, thanks for everyone for joining me for this talk. I went through this a little bit. My name's Ben. I write Clojure and Ruby. You can find me at these places, depending on GitHub or Twitter. I'm either BHB or bbrink. And as I mentioned, I work for Wonder Capital. So in Clojure, we have this focus on pure functions, and rightly so. We try to make most of our code to be in pure functions. And we try to not have effects throughout our code base. That's one of the first things you learn as you start to learn Clojure. But effects is really where the value is, right? We don't get paid to compute arbitrary results and then throw them away. We get paid to send emails or store data or make API calls. So this is really where the value comes in. And the question is not how to avoid them, but really how to structure our code so we can write them effectively. The problem I've run into is that as effects get more complicated, they get harder and harder to write, and especially change them, maybe once they're working. They tend to be relatively hard to test. The feedback loop is much slower, primarily because it's harder to do REPL-driven development when you're working with complicated effects, and they can often be very hard to reason about. And the symptoms that I've run into, first and foremost, and most concerningly, are just bugs that I have actually shipped in my effect code, which are you find out later when something's gone wrong. But you also might notice this if you use certain tools like promises or core async channels, is you might find this effect or this symptom of your code base where you started out with all these pure functions and then you're writing more and more effects and more of your functions like now have return promises. Or they're all returning channels. And you say, what happened to my nice pure functions? They were so handy, and now they're all sort of wrapped up in these async mechanisms. The other thing you might notice is that your tests start getting more and more stub and mock heavy, right? You liked these very easy to reason about tests, and now you have to do this like massive setup to sort of do any sort of verification on your effects. That said, I want to specify that not everything about effects, or these techniques don't apply all the time. Clojure is not a strictly pure language. We can write side effects wherever we want to, if we so want to. And so if you wanted to just do a little bit of logging, or you've got a very simple effect, or you're just trying out an API, you should write the most direct version. Just write the effect inline in your code. There's no need to apply any of these techniques. That's way overkill. So I would say, in general, don't write your code these patterns if and when your effects get complicated or you start finding bugs in them. I'll warn you that I don't have a library here that's going to magically solve all the problems with effects. I just have a series of techniques and trade-offs. If you happen to know of a great library, or you've had experience with something that really solves this problem, I'd definitely like to know about it. But I'm a little skeptical that there's anything that sort of fundamentally changes the set of trade-offs with effect libraries. So just to give you a quick personal history with me and fighting with complex effects, I'll give you one example from some work I did last year, well, over the past couple of years, actually. So we had a bit of startup logic that got pretty complicated, where you had to know, you had some parameters, and you might have to go get something out of storage and then connect to an API and start a sync, and so it got pretty complicated. And our first attempt was core async everywhere. So this was the effect where we had tons of functions, and they all sort of wrapped up in core async. Then we switched over to reframe, and we switched to reframe effects everywhere. So we had lots and lots of reframe effects, all of which were passing commands to call the next effect that we had to go through the whole full loop again. Then we switched to a custom interceptor stack. Then we switched to this library called reframe async of flow effects. Then we moved back to putting all our callbacks in one place. And we finally were looking at, and hadn't yet done, changing from the sort of callbacks all in this one function into maybe finally switching that back to core async, but keeping it localized. So we've gone through a lot of iterations, kind of trying to see all these tools and see which one would solve the problem for us. I never truly found a great solution here. And then just on the side, I haven't used these at Anger, but just I have been looking at things like monads and free monads and logs and sagas, and sort of come up with the same results, although I can't claim to have used them in production. So we like pure functions, but it might be worth asking a little bit more about why, and then look exactly what we mean when we talk about pure functions. So sometimes when people are new to Clojure, they might write code like this, right? Which comes from a sort of imperative background, where they grab some atom and dereference it, and mutate it, and then reset it all in one function, right? And so here I've highlighted the side effects in red and sort of the pure logic in green. And we would say, no, this mixes up those two things. You shouldn't put those together, right? So most Clojurists would recommend something more like this. We'd say, no, pull out a pure function and then call it where you need it. You shouldn't be mixing up those concerns in one function. But not all pure functions are the same. So here's a function that is intentionally named poorly, because I don't want to really give any hints about what it does. But imagine you saw this and you wanted to try it out on the REPL, right? It's a pure function. It has no side effects. But when I start messing around with the REPL, all I get back is this, right? It's just going to return another partially applied function. So this function is pure, but it's opaque. And so the only thing I can do with a partial function or any other opaque object is I can call it. I can maybe combine it with something else to make something else that's also opaque, or I can store it for later. But the API is pretty limited. I can't instantly inspect it. And similarly, to contrast that, here's another function, also poorly named. But if I don't know what this does, I can just start trying it out on the REPL, and I immediately get back data, right? Data is transparent. Data is something I can immediately compare. I can immediately test against. I can break it apart. I have a much richer API with data. And the reason I want to bring up this distinction between functions that technically have no effect and those that are truly transparent is one approach that people take with avoiding effects, or at least controlling them, is just wrapping them in functions, right? Controlling when they occur. So if I have a function like this that is called getPrice, and it does an HTTP request, this would have obviously a side effect. It's going to go out into the world and grab something. And so you could say, well, fine, I don't want that to happen, so I'll just wrap it up in another function. Now this function just returns a function, so hey, no side effect, problem solved. And this certainly does control when the effect happens, and that's not nothing. But it hasn't really solved the problems that I've run into, which are how do I reason about my effects? How do I test them? And how do I actually be able to have fast feedback on what they will do? So in general, in my experience, I would prefer to keep most of my functions pure instead of impure, and then also try to make them functions transparent instead of opaque when I can. I've got a lot of code in this talk. because I want to get into some reasonably complicated examples. They're all in ClojureScript and use async IO, not because I think they're specific to ClojureScript or async, just because once you have callbacks, that really calls out the fact that you are doing some side effects. You could apply all these techniques to synchronous IO, but it wouldn't be quite as obvious. I am going to use some JS promises, and we'll really quickly go through that for anyone who doesn't know how they work. And then just to call out some conventions, if you see exclamation mark at the end of a function, it's a side effect function, and if you see a plus, that means it's returning a promise. And then finally, I'm going to highlight the red effects and the green decisions or pure code. Don't feel like you need to follow every line of code. We're interested in the shape of the code. We're interested in how we're breaking these things apart, and I'll be sure to highlight everything, kind of talk out the parts that are most relevant. So finally, before we get too far, I just want to really quickly talk about JS promises with some code in case anyone doesn't know it. Here's a fake API we have. It's just a simple API that gives fake stock data. At this point, it's got 2 endpoints. You can provide a date and a symbol and get back the price at the end of the day, or you could provide a company name and it'll give you back the stock symbol. So if you've ever used ClojureScript with side effects, if we have 2 functions, each of which do their own API call, generally speaking, with a callback API, you're going to sort of call the first one and it's obnoxious, and then give this side effect, give the callback, which you'll call the second one, and you'll have to give another callback. So you have a sort of left to right nesting that you'll be familiar with if you have used callbacks. A JS promise just wraps up a piece of effect and allows you to attach other callbacks to it. And so you can see at the bottom here, we sort of have we start with our first function, which wraps our original function to provide a callback, or to provide a promise. And then we can do this .then and .then. And the promises just let us make it a little more readable, a little more flatter, and then deal with the fact that even though the first callback itself returns a promise, it will collapse the 2 promises and do the right thing. There's more to promises, but that's enough to get by for the time being. Now you may be saying, I'm a ClojureScript person, I don't use promises, I use core.async, or I use monads in my synchronous code on my backend, or I use reframe. So I have different, I'm not going to have the same problems. And I do think each of those tools has very different trade-offs with respect to the capabilities it provides and the readability. But they also share a lot of similarities that I think means that they approach this problem in reasonably the same way when you zoom out. And that is that all of them tend to be opaque. You can't look inside a JS promise, you can't look inside a callback, and you can't look inside a channel, right? So if you're using them for all your functions, you're still in the same position. They have this infectious quality where as you extract other helpers, they also have to participate in the same abstraction. But that said, they do help with your readability, which is really nice, and they can avoid sort of bugs with construction, where if you have 2 smaller pieces, you can put them together and you're less likely to make sort of silly errors combining them. We're talking through a series of techniques, and they're going to depend on the type of effects that we're talking about. So we'll build up a sort of a compounding set of techniques based on these. So a single effect is just what you would expect. It's an effect that has no relationship to any other effect. So you make one API call, you write one database, make one database call, something like that. Independent effects, just a set of single effects that have no relationship to each other, right? So we have the freedom to either execute them sequentially over time if we want to, or equally well we could execute them concurrently, or some combination thereof. We don't have to wait for them. And then finally, and usually the most interesting, is dependent effects, where we fundamentally can't change the ordering because effect 3 requires the result from effect 2. So we can't sort of break them apart trivially. So for single effects, the basic strategy you may have seen elsewhere is just to break them apart into 2 sections, right? So we're going to have one part of our code that makes most of the decisions. And this is going to be transparent code, right? It'll contain ideally most, if not all, of our conditionals. We'll have most of our code that looks like this, and we can write lots of tests against it, including generative tests, because there's no worry about sort of mutating any state or any of our systems. And then separately, we'll have a smaller part of our code, which is the effect code, right? And this will be impure, it will be opaque rather, ideally very few conditionals, and we can cover it with just a few tests. We could write just a few tests that sort of make sure everything connects together, but we're not worried about covering a lot of code paths in our effect code. So let's look at a really simple example. This is, we're going to, given a symbol and a date, get the price back from this API. So this is what our fake endpoint will look like. And there will be a helper function you'll see, not important in the implementation. It's just going to return today's date as a string. Okay, so here's the straightforward version. It's a lot of code, but we're using callbacks to go all the way through here. Most importantly, this is the mix of decisions and effects, right? We're deciding, first of all, did we get a symbol? Then we're doing then we're doing some pre-processing of our arguments to sort of get them in the right format, making some decisions here about whether or not we should use the date or we provided a date. Then we'll do our effect. Finally, we'll do some post-processing. And so you can call it, as you see on this last line, right? You provide the date and the symbol, and I provided some callbacks for the error case and the happy path as well. And this will just print out the price. So as you can see, everything's in the same place. If you want to test any of this, you have to test the whole thing together. So our technique, as I mentioned, we're going to separate these two pieces, pull out a new function that's a pure function, and all this will do is return a map describing what we want to do and not actually do anything. So here's some example calls. If you give it dates in different formats, it will return either a map that says don't do anything, or here's the get request that you should do. And again, we're not doing anything, we're just returning some data about what we should do. And once we have that, now our side effect function is very, very simple. We're just plugging together those pieces, and there's really only now two pieces of logic. There's the case statements, you could cover that with two tests, and then there's this little bit of post-processing that I still have in there, which is just a single function, so I'm not too worried about that, but you could extract that as well if you wanted to. I'm not going to go over every test for every single one of these examples, it would sort of be laborious, but I will just give you a sense of what the test might look like with this switch. So here's the test of the first version, and the important thing is for even when I'm doing things like testing, did it trim the symbol correctly or did it format the date correctly? All of that requires stubs, right? I'm always adding more and more stubbed code just to stub out this one effect, even though I don't really care about what's happening in the effect. I just want to test this other logic. And when we switch to the new version, I had to cut the code because it gets a little long, but we basically go back to, we have one version where we only have to stub the one case we're actually doing we're calling the get request, and make sure that that sort of is all tied together, and everything else can just be tested by like comparing maps or parts of maps. The tests get much simpler, and the REPL experience gets much simpler as well. So independent effects are basically the same with one little wrinkle. This is the same slides before, but now we have this new question of do we want to run our effects in sequence or concurrently? So our new example is instead of getting one price, we're going to get a sequence of prices and then take an average of them, given a number of dates. So we have the same API as before. And here's our straightforward code. We'll reuse our example from before where we get price. And now, if we want to do them in sequence, at least with sort of vanilla callbacks, I should say, you sort of get this recursive situation where we have to check, do we have any more dates left? If so, make one request and then call the function again, right? We have this recursive sort of structure to get the callbacks to line up. And once we have that, it's very simple to add this mean prices thing that just says get all those prices, and then when you're done, just call this this mean function to get the average. So we have this structure right now, and one effect that we can do to actually simplify things, somewhat surprisingly, is to go ahead and make these concurrent. So using a technique of promises, which there's other libraries that have something similar, but again, not our problem, we can actually convert each one of our calls into a promise and then use this function promise.all to just run them all at once. So now we've just cut out that entire hand-coded recursive function, which was somewhat complicated, could go wrong, and now we just say, yep, map over these, go ahead and execute them all in concurrently, and then we get one callback just to go ahead and get to parse them and do the average. So all we've done is switched from this to this and actually simplified our code. And the nice thing is once you simplify that code by making them concurrent, you get an option to take the pure and the impure parts apart. So this is our old code where we're still mixing up all the red and the green, right? But we can just pull out, we already had our price_rec function that returned one map. Well, now we just map over each date and return many maps. So we've pulled out all that code, and our site affecting piece is completely free of logic. We just continue to call promise.all, but we've just connected those pieces, and we can test all of the pure stuff. So this may sound very familiar to you if you've seen any of these architectures or seen that talk. It's mostly a rehash of those ideas. But the part that I always was wondering about and always ran into was this dependent effects part, right? So that's all fine and good when you have very simple things, but what do we do when all of our effects sort of fundamentally are connected and have to go in a certain order because we need the data from each one? So I'm going to have a more complicated example because I think this only sort of applies in more complicated examples. So this is going to be a lowest price function. And we're going to have a couple of options. So we can provide a company name or a symbol, whatever we happen to have. We're going to go ask the API for all the dates that it has prices for. Then we have some logic in the middle, say get the last 5 of those. We're going to go then back to the API, look up all those prices, and then finally pick the lowest one. We have to add one more endpoint to our fake API here, and that is the dates available, which we can provide a symbol and get all the dates back. So this is what our function looks like. And as expected, it's reasonably complicated, right? But we can see that we have the structure where we have sort of a decision up front, then some effects, then some more decision code, then some more independent effects, and then finally some post-processing. So in code, the straightforward version looks just like this. And it has the same sort of symbol, shape, I should say. If you start down here, we've got that decision, then some effects. We may do a second effect here. Then we've got this middle processing. Then we've got this set of promise.all, which is all those independent effects, and then the post-processing. So we've got the same structure of decision, effects, more decision, and then effects. I think our first instinct when we see code like this is to say we've got a big messy function, let's break it into smaller functions, each of which we can understand, and then we can use something like core.async or promises to pull those things apart and recompose them. That's certainly what I did when I ran into examples like this. And so if this is our straightforward, we do use a little bit of promises, but mostly callback-y structure. You can imagine just pulling out a new function. So now we've got smaller functions where we just say, yeah, let's get all the prices in one place, and then call that from the middle function. And then finally, we can do some promise magic and kind of make this bottom function read a little bit nicer, which is nice. And we've got this new structure, right? So we've got smaller pieces, and we've got a little bit more readable code at the bottom. But fundamentally, I think we need to be honest about the limitations of tools like this, right? We've improved our readability, and certainly we may have fewer bugs in the combinations. We've combined those 3 functions without error. But I think people have an illusion that promises or core.async or other tools are the silver bullet, that they are going to solve the effect problem. And all we have to do is apply them across our code, and things sort of will just work. And that hasn't been my experience at all. I found that they remain opaque, they tend to infect our code, and they have a lot of pulling pieces apart doesn't necessarily actually help with comprehension. So the first thing to note of why they don't necessarily help is they're not really simplifying anything, right? They had those benefits, but our graph looks exactly the same. We have not changed our dependency graph at all. We remain just as complicated when we think about the fundamental flow of this function. And secondly, as we've noted, we still have this combination. Everything is wrapped up. All the red and the green is each function has some red, some green. We haven't really made any clear separation. And finally, at this level, effect functions are extremely leaky abstractions. I'm not against abstraction, I certainly, when I pick a HTTP library off the shelf, I don't want to know about all the stuff that's going on in the covers. I want to program to that abstraction. But in this function, we are talking about working with an API which has multiple parts, right? We are very much interested in the details of exactly how we talk to that API. If we look at our functions here, get prices is not just getting prices and I don't care how, right? I am talking to an API. There are cross-cutting concerns between these three functions that I very much may care about. So first of all, we know that effects are some of the most expensive parts of our code, especially when we're talking about network effects, but in general, very, very expensive. So I might very well care about how getPrices is doing that. Is it doing it concurrently or is it doing it sequentially? Is it repeating a request that I might have done in some other function, right? I might have caching concerns. I might be able to say, well, this is, if it's new enough, I'm happy to not make this call again. Failure modes. If I have one function that is doing an API call that is timed out twice but succeeded on the third time, I might have a very specific strategy for how I want to proceed with future failures. Or maybe even have a circuit breaker pattern where I say, actually, if this one failed, I want to just like stop doing the rest of these, right? And finally, if any, in this case it's all read functions, but if any of my functions are writing something and the other one expects it to read, I very much care exactly what exactly was written out. I think that all of this speaks to these cross-cutting concerns, and then the final one is just comprehension. If you come back to this function in 6 months, or if a team member comes to this function, do you want to be, how many small functions do you want to be hopping around to try to understand when they have a bug in it, or when they want to say a simple question, how many GET requests are you going to make here? Do you know? Do you have to jump around to like 5 files to figure that out, or even 5 functions? I think it actually inhibits comprehension instead of letting you zoom out. I think about this tweet a lot, and it talks about a more general issue, but I do think about in the context of effects that often when you sort of optimize for these small abstractions, hiding little parts of it, you actually lose the bigger picture, and you can lose the ability to make more important optimizations and abstractions. So if breaking into smaller functions isn't going to help, or if it's at least going to have very limited benefits, what are some things that we can do? So here's 6 techniques that I think could help. So the first one is types, and I don't know anything about types, but I do know that people use them, right, to give some sense of what would I say? To give some confidence in their side effect code. And certainly if I haven't used core type myself, but if there was a place that I would want to use it, it would be in this effect code, right? To like try to get some sense of that these things are connecting correctly. So the first technique is avoiding decisions. And this comes from a post from John Carmack at id Software, and he talks about this, about how even in their software, which is much more performance intensive than most things, at least I write, they're worried very much about optimizing each frame of the game loop. And he has, in this post, recommends inlining code and avoiding special cases. He says, I would rather you have a consistent code path, even with side effects that might not be perfectly optimal, than to try to special case and try to do these minor optimizations of avoiding a call here or a call here. So if we go back to our example here, we have this decision up front, and then we can ask ourselves, depending on our app, can we just avoid that decision entirely? What if I just always got the symbol, right? And then I later on decided, well, I'll throw it away if I don't need it, right? I just have a decision downstream. That can actually simplify our code. So if we go back to the callback version, which is sort of the straightforward nested version here, I've got this decision at the bottom where I'm deciding, well, if I have a symbol, then I'll continue, but otherwise I have to go back and get the symbol itself. What if I just take it out and say, you know what, in either case, just go ahead. Either way, I will call this helper function. And in one case, I will call it with the symbol, and otherwise I will call it with what I got back from this GET request. So that's one way to avoid decisions, is just always perform the same sequence of effects, right? But another way, if you have like a big read API, let's say you're doing database calls, You could maybe have a larger request than you strictly need and sort of join across more tables and then just throw away the data you don't need. Or let's say you're reading from local storage or something. Maybe you just get everything. Instead of optimizing and picking this one or this one, just get a bigger set and then decide, well, I'm going to prefer this over this and throw it away. And if you have write effects, you can do the same thing with idempotent writes. Maybe you don't have to check, do I strictly need to make the write? Just always make it if you know it's going to be safe to do. So again, if in the local storage example, instead of checking is it there and trying to optimize or decide from a previous read if it's there, just always write it because who cares? It may be totally within your performance characteristics. Okay, so once we've taken away that decision part, we can now apply this old trick of separating the pure and the impure functions. So here's our code where we don't have that decision anymore, but we still have the green and the red all mixed up. And we do the same trick where we pull out a whole bunch of pure functions. These are all the pieces of the request that we might want. And you'll notice this goes off the slide, which brings up a real trade-off here is generally when you do this trick, you will add lines of code. And so I think that is a downside and one reason you wouldn't want to do this for very simple cases. But as your effects get more and more complicated, I think this pays dividends. Okay, so now we've got this whole host of nice pure functions above, and our side effecty code, again, becomes all red down below. There's no decisions there, just plumbing. Okay, so then the next technique is the opposite of what we saw before, where we were talking about how if you pull out lots of little functions, you lose comprehension potentially. And so we're actually going to do the opposite and take our helper function and just go ahead and inline it. Now there's no hops of indirection, and I can very quickly, when I look at the red, see how many GET requests I'm going to do. Okay, I do one here, and then this sequence here, right? So I've actually, and I can potentially do cross-cutting concerns like failure handling or other things all in one place. Once I've done those two techniques, now I can apply something like core.async or promises. Here's my inlined version. Now I can apply some promise magic, which isn't super important, but the important thing to notice is I went from this sort of left to right, continually indenting thing to this flatter, more readable structure. So this might help me when I go back and read it. I can reason about it more clearly. And then finally, look for places where you can make what I call bigger effects. So the analogy I'll make here is doing multiple REST calls instead of doing one GraphQL call, if you're familiar with GraphQL. If you're not, it's not important. It's just you can sort of specify declaratively this entire shape of the data that you want, and the server will sort of match that request and give you back sort of exactly what you had asked for. I think when you initially see this, there's a question of like, are we just moving the problem around, right? Someone has to do those complicated effects. Maybe the client's not, but the server is. And I think that the point here is that it's fine to have complicated effects, but what you would like to do is put those into this position such that you are reusing those effects a lot. You have that in a code path that you have very high confidence because it has so many clients. Complicated effects aren't necessarily bad. What's worrisome to me, and the problem I've run into, is when you have complicated effects that are spread out over your code base. So each one is only maybe used in one specific code path and has to be tested individually. If you can actually collapse your effects into a smaller area of your code and then have high confidence, either through testing or just honestly through real-world code use, that's way better. In fact, I've had some projects where the effect piece is so commonly used and so simple that there's no test needed because it's like if the app boots, it works. Like those pieces are all connected. Like it's literally so easy to manually test. It's not even worth having an automated test. So this example, we'll have to add one last API, and this is, again, me moving now some complexity to the server, is a prices endpoint where I can provide a date, many dates rather, and a symbol, and get many prices back. So with our graph, we've gone from these two independent effects here that we have to manage and just turn that into a single effect. So if this is the example where we have this bit down here where we're doing the promises call that does many requests, this is going to switch it and just do a single request. So now it's even clearer how many GET requests I have. I can just see them immediately. I have this one, and this one. They're all individual. So I can say there's always going to be 3 GET requests here, and I know exactly how they line up. And they happen in every case, right? And my only question is, if I want to know when things happen, go look at the pure functions. Try them at the REPL, try them in tests. So here's our 5 techniques just to review. Avoid decisions if you can. Question whether or not you actually need to optimize your set of effects for performance. Go ahead and separate the pure and the impure functions. Actually inline as much as you can to actually be able to read it and have cross-cutting concerns. Then finally, you can use things like core.async or promises to make it easier for you to understand the flow, and then consider building bigger effects and find places to do that. And if we zoom out a little bit, that really comes down to 3 things. 1, look for opportunities to simplify that graph, simplify your set of effects. 2, use pure functions. We know that pure functions aid in making robust programs, so use them as much as possible, even in your effect code. And finally, when you've done those 2 things, look for ways to increase the comprehension of the code. Use your brain, aid your brain in its ability to actually reason about these things. Don't break things up, make it harder to fit into one person's head. So if I want you to get one thing out of this talk, I think that promises and things are useful and help in many ways, but they don't simplify your effect graph. They aren't going to solve this effect problem, and so you can't just apply them across your code base and expect to not have the same sets of problems. You'll just have a new set of problems, but fundamentally you're going to have a hard time reasoning and debugging that code. Our instinct with pure functions is to break them into smaller pieces, and pure functions abstract very well, and it's often useful to break them into smaller pieces because we can compose them really well. I think when you hide effects in smaller functions, it actually often has more cost than gain. So think about inlining instead of breaking things apart. Even at the cost of having potentially reasonably long functions that very clearly capture your complexity. If you have a long function with very complicated effects, I think the answer is to say, why is this so complicated? Can we fundamentally change this? Is there anything else we can push on? Not hide it by trying to break it into small pieces and pretending that complexity doesn't exist. And once you've done these 2 things, in the remaining effect functions, you want to optimize for simplicity, transparency, and comprehension, if at all possible. I will put the slides online, and I've got the code as well on GitHub. But all of these talks informed this. They're all really, really good. I would highly recommend all of them. I know it's a lot, but they're all touch on aspects of this in various ways. So highly recommended. And then finally, these will be places where I put the slides. Are there any questions? Yes?
We have some of these really complex chain things. We have 3, 4, 5 requests that may succeed or fail, plus processing. Why don't you use a state machine?
So so the question was, if I get this correctly, you have very complicated chains, and they have a lot of decisions in the middle, and the question is, why not use a state machine? Is that right?
Yes.
So you can absolutely use a state machine. In fact, I think that the observation is anytime you have async effects, you actually are using a state machine. It may not be your state machine. You're using someone's state machine behind the scenes, right? So I think that's a perfectly great mechanism. The question is, can you, how do you want to use the state machine? If you want to embed your state machine very clearly in your effect function, that's great. The thing that I have had worse results with is things that try to embed a state machine somewhere else in your code. So I think the reframe async effects thing is really cool, and it sort of tries to encode your state machine as data. And ultimately, that was overall more confusing than just having the code inline in one place. It was another abstraction on top of it, and again, everything had to be broken apart into pieces so that state machine could work. So if your state machine has to break everything into small little pieces, I think you're actually going to lose your comprehension. If you can embed the state machine in one place and read it top to bottom and understand it, then great, I would use it. But I'd be wary of the costs of an explicit state machine. If it's someone else's state machine, like core.async basically has a state machine behind the scenes, great, use it. That's fine.
I worked on things that had extremely complicated effects.
Yeah. That
were sequenced and maybe could go wrong and all kinds of, and it was all done with state machines and all worked great.
Yeah. Well, that's another approach too. If you guys, this is certainly just an experience report based on what I've done. If you've gotten good mileage out of the state machine, then definitely use it. I think that we had a hard time when we used one particular implementation of a state machine, reasoning about the pass through it, and so it didn't again actually simplify our problem domain. And so we would have questions about, wait a second, when will this actually happen? Who's going to fire this event? Will it actually come back and find it? So you know what all the transitions are in the state machine, but then the question becomes, wait a second, who's going to trigger the state machine? Where are all the effects that are going to come back to the state machine? Who's going to fire event X and event Y? And we had a lot of questions about, when is that going to happen? When we know what will happen if the event is fired, but who's going to fire the event and under what logic? So that logic was the stuff that got hard to understand. Your mileage may vary. Yes?
Really early on, you had a slide where you broke down, like the first or the second one, you broke down the data-based DSL to
yes.
express the flow. What happened to that? Where did that go? I mean, like it stopped, like you didn't say when it's using the promises DSL for the same kind of thing, but like.
So this guy, sorry, I went really far. This guy.
Yeah.
Yeah. It stayed around actually. It's present every time I do the same separation of pure and impure functions, I'm using the same maps. So this is the example with a simple version where we get back a map. And I'll skip ahead real quick. When I have independent ones, I'm actually reusing that exact same function that returns maps, but now I'm just doing give me a list of those maps. Same technique for independent ones. And then in fact, if you jump all the way ahead to dependent ones, good, I should have these closer together. Okay, same thing. There's one that gets the map, function that says, well, what will the request for all the dates look like given a symbol and a provided symbol? So that encapsulates all that entire decision. So I keep doing the same technique. Sorry if that wasn't clear. It's always the same thing. The pure functions return maps. The maps describe what to do. And there's a minimal translation layer between what the map says and what the effect function does. There's almost no code there. It's just plumbing. It's just saying, pull out this stuff, pass it to the API. And so that's a really good point. When we talk about these maps, or whatever, however you want to encode it, I would default to maps. But when you have these maps, you want that representation to be as close as possible to whatever the effect function is going to be, because what you don't want to have is a lot of complicated logic to translate the map you had into something that you can actually do. So in my code, it was literally like pull out the URL param, and then everything else just has passed straight into this HTTP library with no translation at all. So you can basically like hand inspect that and know that it's right. Good question though.
I have a suspicion that a lot of the difficulty in this example is predicated on using REST as an interface for a distributed database. I'm not sure I'm not sure it really matters, but I'm not sure. I think we're all mistaken in thinking that's a good idea.
No, agreed. And that's a fantastic point, and I think that like many of these problems could be solved. I didn't expand on the sort of bigger effect to this point, but you can imagine saying like, actually what I have is like, give me a symbol, and then off that hang all of give me all the dates for that symbol, and you pass in a parameter to your database and say, give me the top 5. You can imagine making a really big request. And in fact, that's the observation of something like GraphQL. It's like the bigger you make the request, you have less chatty protocols, you have less complicated custom dependent effect code, right? So that's a totally valid observation. In my more real world examples, it was often things like, even though we had relatively big requests, one of them was to a server to get some data, and the other one was to the browser, and the third one, I guess that was the main two, was like, and the other one was to some global state in the client side, right? So even though we had relatively big requests, we still had requests to 3 separate systems, and we were trying to order them. So we sort of were at some point limited by this. We couldn't make our requests. They sort of spanned multiple systems. But yes, you're right. In this case, talking to the same API, I think you're right. That's a really good instinct of saying, like, why couldn't this be one request across this entire like get low price thing, right? Does this have to be a bunch? It's a good point. Yeah.
Well, so you kind of touched on this, but like when you were talking about consolidating really complicated effects,
Yeah.
you had a slide where it showed REST and GraphQL.
Yeah.
I think you're making the case that GraphQL could be a good solution for that because it's complicated code, but it's well trafficked.
Well trafficked, that's a great term. Yeah, exactly. That's exactly the point I'm making is like, and not necessarily, I'm not saying like GraphQL specifically, but things like GraphQL, and not just in GraphQL. If you're going to interact with the file system, let's say, right? Do you want to have like 10 different dependent things that structured, or do you want to have one declarative thing that says, make this whole directory look like this, and then one well-trafficked piece of code that takes that and goes ahead and actually performs that manipulation. This is the exact same observation as something like React, right? React says, give me a description of the entire thing, and I have one very well-trafficked piece of code, in this case, a third-party library. I will go do this for you, right? The virtual DOM, right? I will go do this for you, but you just tell me what you want, right? And I think that pattern obviously will exist for things that are like React, where you have sort of a, if you will, like a closed space where you're saying like it's just the screen of the DOM, but it also works for open systems. Like you're not going to model the entire state of Twitter, let's say, and then like just mutate it and have a new Twitter, right? That's too big to keep in memory. But you could say, if I want to talk to some API, I will give it as much data as I know at a certain point and let the server figure out, doing as much as possible. If that's, again, well-trafficked. Dependent code isn't bad, just low-traffic dependent code is not good. Spread out all the place. That's scary. Yeah, but really good question. I didn't repeat either of those questions, sorry. Okay, I'm going to try to repeat this question.
How many years have you been thinking about this? I know I've been talking to you about this for like at least 2.
So the question is, how many years have I been thinking about this? I've been thinking about this since I saw, who saw functional core, imperative shell, or boundaries? Has anyone seen those talks? Oh, go watch those talks. So and as soon as you see those talks, you'll know what why I did this talk. So those are two really good talks. I know boundaries is online. Functional core, imperative shell might be behind a paywall, but I'm not sure about that. I think that might be one of the ones that it's a screencast, so he might have opened it up. But okay, so that was like 2012 that I saw that, and so I think since then I've been on the hunt for the library that's going to solve the dependent effect problem. And in fact, I think I presented to this very group some, in retrospect, poorly thought out solution to this like 2 years ago, which is the log-based stuff, which didn't work out in practice and skipped on that. So yeah, probably rough in some way, shape, or form, this since 2012, I guess. But only in the last 2 years have I got to put these techniques into practice and sort of decide that there's probably not a silver bullet here. There might be. Not for any of the problems that I have. Like talking to my friends who do a lot of functional programming, they're like monads, obviously, but playing with that, it's the same problems. It's like all you've done is control the order of operations. You haven't gained any transparency. You haven't gained any ability to REPL-driven development or look at it. So I don't know. Maybe it's just I haven't used them correctly, but
in a very real way, if you don't worry about all the laws, a promise is no different than a monad.
right,
The libraries may not implement all the laws of monads.
right.
But it's the same thing as if you were using monads to achieve that goal.
Exactly, right? And I think that's a really good observation. So the observation was just that monads and promises share a lot of properties. And And I just haven't had, I guess I should have said more clearly, like, I don't think promises are bad. I don't think core async is bad. I think they're awesome. I just think that you should like isolate them to one part of your code and try to keep that code part small and high trafficked. What you shouldn't do is think like, I have monads or JS promises. Therefore, my solution is to spread that out throughout my code, and there's going to be no problems. Yes?
Just an observation. This whole presentation thing is twitchy. I'm just like twitching because my mind keeps going up and down the abstractions. Like, should you go that way or that way? Like, how do you... There's no answer to it, is there? Like, this is the kind of stuff that means we will have jobs.
Yes. So the observation was that just it's an uncomfortable subject, and there's no sort of way around it. And I think that's exactly right. Like, I think that you can imagine this like, so if you start with callbacks, right? I mean, callbacks are fundamentally opaque, right? They are, when you get a callback, you can't look inside it. All you can do is call it. As soon as you have that, and as soon as you realize that you have an effect and you have a callback because you have to do some logic and another effect, there's no way to get out of that trap, right? No matter which way you organize your callbacks and move it into this other opaque thing or redo this, like, unless you're going to rewrite Clojure, a complete DSL that encodes everything in data so you can like pass it back and look at it, and then you have this different set of problems where you have to like implement every computation you want to do in this fake data language, right? You always have this problem. If you look, if anyone has seen this core async flow library, it's really, really cool. But the first thing you'll notice, you're like, cool, it's data, and it is data, except for all the important computation that you want to do, which is, of course, back in your reframe effects, which are then encoded in opaque code, right? Like, just code is opaque, right? And when we separate these things, and we have a barrier of opaque code, you're not going to get around it. So I think we should look for these things that help us understand it and simplify it where we can. I know, right? This was not even the scary version, right? And that's often the first thing that people realize when they've got callbacks or whatever, is that like, or you separate stuff, is that error handling is even worse, like in that case. At least here, we have one place to do our error handling. That, I think, in itself is a win.
There's another big win if you go back to where you were. So encoding this as data is another monad type thing.
Right, good point.
Because if you look at what Haskell does, you do things in I/O and theoretically at least, the function runs and it produces something, and then I/O takes over and
it will do it all.
Effects.
Right.
Right. The nice thing about this, about returning the description of what to do, is you actually can test that.
Exactly. That's such a good, yeah.
If it's not working, you can look at the output.
You can look at the output.
See, that was supposed to be a no optimal case, or it's supposed to be a put instead of a get, or
right.
Instead of waiting, some weird thing happens, you have to go look at the packets or look at the server, see what.
Right. When your promise goes wrong or your monad goes wrong, how do you know? How do you know that went wrong? The only way you can see that is by seeing that, oh my God, I called the wrong, that got the wrong request on the wire. My database looks wrong now, right? You have no other method for that. Now maybe the type system helped you and caught some of those errors for whatever the type system, the power of the type system that can actually help you. But your only solution is to look at what happened in the world. Whereas if you break into data, you can at least get a handle on what you're intending to do, and if it's well trafficked, you have a very low risk of a bug in the code that goes from no op map to actually not doing anything. That code is very trivial to verify. Absolutely. Has anyone had experience with, unlike highly dependent effects? You had your experience with the state machine is another really great technique. Anyone else had experience reports of stuff that worked or stuff that didn't work? Anyone had an experience of a code base that has where everything is returning channels? Cool. Okay. So thank you for all the good questions. Right, I think that's the end. If anyone else has questions, I guess I'll be around afterwards. Thank you, guys.